about machine learning today. So just for fun, I put together a little algorithm that's running on a neural network yesterday. And what it does is it will identify anybody in the room who's looking at your Facebook account instead of listening to me. And it will go through and trawl your photos of the meals you've had in the last few weeks. And I'll be able to predict from that what you're going to have for dinner tonight. Now, I'm only joking, of course. I wouldn't do that to you, although it does raise the question that there are ethical issues in machine learning as well. But more seriously, if you had to ask Siri for directions of how to get here today, or if you came here with a grab car, or if you checked your Facebook account this morning, or if you have one of those new cars that can, drive itself and stay in its lane, you've already been touched by machine learning. Machine learning is almost pervasive. It's embedded in all sorts of things that we don't even realize today in terms of technology. Now, I've only got a very limited time to give you a little bit of an insight, a little bit of a view of some aspects of machine learning. I'm not going to go too much into the technology and the products. You'll hear from other people about some of that later today. But my objective is really just to give you a little bit of a sense of what it is and why it's important. Coming from Gartner, we provide independent and objective advice that helps people make technology-related decisions. That's not just what technology do I buy and how do I negotiate a good deal, but it's also around the strategy. How does this impact the business results? How do we drive innovation? How do we manage risk in the organization? And that becomes more important than ever because the rate of technology-related change will never be as slow as it is today. Slow? Of course it's not slow, it's fast. Well, just wait a couple of years. In 3 years, you'll think today is slow. Machine learning is certainly one of those areas that is rapidly changing. 10 years ago, there were probably only around 10, that may be a slight exaggeration, but there weren't that many examples of machine learning in the real world in business applications. A lot of activity in the labs, but in the real world it was very hard to find. We believe that in 10 years it will be hard to not find. It will be basically pervasive. There'll be very few business applications that aren't using machine learning in some way. So that's the kind of scale of disruption that we're seeing, coming from nothing in the span of only really a few years, less than 20 years. Now, one of the things we're seeing in Gartner is the way that technologies move through what we call the hype cycle. Most hopefully have seen this, and it really tracks the maturity of technologies. Gartner tracks over 2,000 individual technologies. We publish them in dozens of hype cycles. You won't be able to read the detail, that's not important. But here's just two examples of current hype cycles for data science on your left and for smart machines. And there's dozens of others. And I've highlighted with the yellow highlighter, machine learning is at the peak of hype. What does that mean? Well, a technology starts, there's some kind of trigger. Someone has a great idea. As they start to develop that, maybe others get involved. People hear about it and say, that's exciting, that's going to solve all our problems. And we end up with this rise in the hype. People have inflated expectations of how this technology will benefit them. And then as we go, we realize, well, actually, it's not very mature yet. There's got bugs, there's risks, there's all sorts of data issues or whatever it might be. And we go through this trough of disillusionment. Meanwhile, things keep going, people keep working and refining it, and we come out at this plateau of productivity. So that's the hype cycle of Gartner. Machine learning is definitely at the top of the hype. So this is a timely event to start to talk through, well, what is machine learning? What's real, what's not? But be aware there will be lots of hype. There'll be lots of promises, lots of offers, lots of technology being offered that will have some benefits, but there'll also be some hype, and you need to be able to sift through that. Now, also on the far right, I've highlighted speech recognition on the right chart as a relatively mature technology. 15 years ago, it was a bit buggy, but that's fairly mature now, speech recognition on its own. The reason I highlighted that is I'm going to come back later to the idea of speech recognition linked to machine learning. and chatbots and conversational artificial intelligence. So just bear that in mind. One of the inflection points in this last 10 years of machine learning coming from almost nowhere to being quite pervasive is what we might call the Big Bang of 2012. So there were some underlying trends that came together. By the way, 2012 was when we talked about the nexus of forces, mobile, social, cloud, and information, coming together and influencing business. But behind the scenes, this was going on. The rise of graphical processing units, GPUs, which are much more powerful than traditional CPUs and can do a lot more parallel processing. Now, they're used obviously in graphics, but they can also be used in other compute tasks. So high-performance computing based on the GPU technology had sufficiently advanced to be able to crunch lots of data. As it says, a million-fold improvement between 2008 and 2016. So in the middle of that, 2012. Deep neural networks. So neural networks had been around, but the ability to extend those, to be able to go deeper, more complex analysis and learning in the application side, linked with the hardware of the GPUs, and add big data. We were getting more information from things like social media, from the early days of the Internet of Things, connecting sensors up and collecting more and more data. And these things coming together is really what was an inflection point in the rise of the learning machines. Gartner does a CIO survey. We've been doing this for about 18 years, and this is a listing of what CIOs are saying are their top technology priorities for this current year. So, advanced analytics. Hey, no surprise. We used to call that BI. It's been on the top of the list probably for 10 years. It probably will be next year. Analytics. Internet of Things, digital security, business algorithms, and number 5 is machine learning. Why so low? Well, actually, just stop for a minute. Machine learning on its own is number 5, but machine learning is actually embedded in almost all of the others. So advanced analytics, predictive analytics, uses machine learning. The more sophisticated tools use machine learning technologies. The Internet of Things, we're starting to see organizations wanting to push intelligence out to the edge of the network so that the sensors can start using algorithms, using machine learning to make decisions and respond in terms of asset maintenance and things like that. So that's being embedded. Digital security, looking at intrusion prevention, looking at patterns and using machine learning in that. Virtual customer assistants, having these chatbots and voice-based customer assistants, again, based on learning. So it is actually much more important than it might seem from that number 5 position. It's actually embedded in almost all of those other activities. Autonomous vehicles is a well-known one as well. From our CIO survey, I just want to share one short case study of a university in Australia that's been looking at these machine learning technology. And this is basically using IBM Watson to support student services on campus at the university. We've lost the sound. So this is the CIO of Deakin University. Apologies, we've lost the sound, so don't worry. He's talking about how they're using the IBM Watson technology on campus to provide student services. So students can use natural language to type or speak and ask questions around curriculum or other services on campus. They've set up a laboratory where they're doing this. They're working with their IT folk and also some of the faculties. You may have noticed a t-shirt there. The guy said, "I'm helping train Watson," and I'll come back to that point. He also talks about using a number of different vendors. So obviously IBM's at the big end of town, but using small vendors for different parts of this as well. So look, apologies that didn't work, but hey, technology's like that sometimes. One of the points I made around the people training Watson is that these things don't think for themselves. Buying a neural network, buying a learning machine is a bit like hiring a 3-year-old. right? They're actually not very useful until you train them. They're not very useful until they're 18 or 20 or 25. And so training the neural network, training the learning machine in what's important, training it on the data, and Harry talked about this supervised and unsupervised machine learning, for example, but letting it learn and train. It doesn't do it by itself. And so one of these predictions here is that organizations will need to have people dedicated to training the machine. When Gartner releases a new product or changes our process, I have to do some computer-based training. So the computer teaches me. But in future, we need to teach the computers. Now, once they learn, once they've optimized the algorithms and they've learnt, from the data, they are able to start to make, some autonomous decisions, at least the advanced versions of machine learning. But to begin with, they're actually not very smart, and we have to train them. So what is machine learning? What's all the fuss about? In its simplest terms, it's about machines learning from data without being explicitly programmed. Right? It's not a whole series of if-then-else statements that guide the machine. It's learning from data. It's basically a technology related to data analytics, data science. The machines learn from the data in either that supervised mode, where there's a specific set of objectives and algorithms and features that you're training it on, and you're checking and you're correcting it, or in an unsupervised way that is a little bit more exploratory, just looking for identifying interesting patterns and things. Now, two quick examples. There was a mention at the start about IBM Watson winning the game of Jeopardy, which is quite sophisticated and very language-based. Well, in the late 90s, IBM Deep Blue beat a human in chess. Okay, from chess to Jeopardy. The difference is Deep Blue was programmed to play chess. IBM Watson was not programmed to play Jeopardy, it learnt. It was trained and it learnt to the point where it could beat a human in a more sophisticated game. Self-driving cars. In 2005, there was a university team that entered the US Defense DARPA challenge with a self-driving vehicle that completed a course. Now that was pretty exciting at the time, but that vehicle was programmed to follow a particular course and to operate. Google's self-driving car that started going out on the roads in 2009 was not programmed, it learnt. And all of the others, NVIDIA and various other companies doing self-driving cars, are using this machine learning where it learns how to go around obstacles, what different road signs might be, how to distinguish between other vehicles, between people and animals as it's driving along the road. So again, the machine has to be trained by people to do that. Now, these things can be used in a number of areas. Mobile devices, I mentioned, people with Siri or Cortana or Google Now on your phone. Can be embedded in applications. It can be linked to sensors, both using the data from sensors, but also putting intelligence out in the sensors. Security, networks, and various appliances, smart fridges or things in the home that will have this learning connected to it. So basically, in simple terms, we've got input data. There's a learner, which is now a machine that needs to be trained, and then there's some output. So we feed the learner the data. We're either doing this in supervised or unsupervised mode, and then we're coming out. We're exploring. Typically in an unsupervised is exploratory, just looking for patterns in the data, looking for anomalies, or a more supervised mode where the machines are learning to classify vast sets of data. Or used to predict certain behaviours or certain activities in terms of asset maintenance. So that's the simple message of it. The machine is learning from the data. The more data you feed it, the more that it learns. Now, a lot of the use cases are in retail. People want to sell more, so they're very interested in machine learning. How can I understand the behaviour of shoppers, whether that's online or in a mall next door? But there's a whole lot more. Traffic management, healthcare, autonomous vehicles I touched on, risk management, fraud, money laundering in financial services. There's all sorts of applications that machine learning is being applied to. I don't have time to go into all of those, but it is very diverse, and I'm sure there's something in your industry there as well. Machine learning is basically this idea that the technology discipline, right, where we're getting business problems, we're solving them through extracting knowledge from data. So we're looking at the data, we're running it through algorithms, we're fine-tuning that, and we're getting some meaningful information or insights from that. Now, machine learning, in a shallow sense, can even be things like regression analysis. So this doesn't have to be the really deep, complex stuff, but below the general machine learning is this idea of deep learning, where there's more iterative approach, there's more stages to the learning, and there's a more complex neural network and sets of data. And then beyond that is this idea of artificial intelligence, where the machines are able to, take decisions, take actions based on what they've learnt and the patterns of data coming through, possibly in real time. And this is things that in the past we thought only humans were capable of doing. Now, this doesn't mean that the machines have consciousness, that they will replace humans completely, but there's things that they're starting to do that in the past we thought were more human-like. But it is very limited. Face recognition is one of the examples where machine learning has come a long way. Harry talked about Facebook's deep face being 97% accurate. What he didn't mention is that's more accurate than humans at recognizing faces. Google, Microsoft, Baidu, various others also can recognize faces more accurately than a typical human. So this technology has come a long way. As our resolution of images has improved, as that graphical processing capacity, the high performance computing has improved, the machines are able to learn what are the features of a face. Rather than being programmed to say, look for eyes and look for, different features, it's actually learning from the data set and being trained. When it gets it wrong, no, that's not a human face, that's something else. Right? So the people training it so to the point where they're now more accurate than humans in face recognition. But it's easy to get it wrong. This is based on a real example where the computer was being trained to recognize a military tank. Unfortunately, it thought an elephant or a whale shark or a Volkswagen Beetle was also a tank. And if you're driving out of a war zone with your family in your grandfather's Volkswagen, you don't want to be mistaken for a tank. Right? So again, this isn't learning on its own. They need to be trained, they need to be refined, and improve over time. And the data that you feed it will determine some of the validity of the results as well. So warning, they're not perfect. A couple of examples again just to highlight medical. Taking an image, taking a medical image of a brain or an organ, and then the machine being able to identify things that a human couldn't pick up at a pixel level, looking for anomalies, looking for weak things that we might miss as a human to pick up maybe early signs of disease. Self-driving cars, turning those surroundings into controls. Right? I need to steer around an obstacle, or I need to slow down, there's something ahead. So turning that information, learning from its surroundings, and turning that into behavior and action. Some of the most exciting areas in this more advanced machine learning are around image recognition and machine translation. As I say, this is basically just analytics and data science at its basic level, the shallow machine learning, but the deeper learning is around some of these types of things. And we believe that in the future, conversational artificial intelligence systems will be the real breakthrough. They'll be the things that drive a lot of power. So we had the lovely Amelia introducing us here today and running the event. Well, IPsoft have a virtual agent called Amelia. So maybe when I come back in a couple of years, the virtual Amelia will replace the real Amelia. I hope not. But you can talk to it. You can ask it questions, just like Harry did with Watson at the beginning, and get solutions and get advice. So this idea of talking without needing to know the specific keywords, and the machine not only understands the language, converts that to text, but can analyze the meaning. If I talk about a network, am I talking about an IP network or a social network? Right? So, using those words, and as we know, in Indonesian language, there's more work to be done there. English language, Chinese, a lot of work going on there, but it will come. It will come to Bahasa as well. To the point where we think by 2020, the average person will have more conversations with bots, chat bots, virtual personal assistants, virtual customer agents, and other things than they will with their spouse. Now, I'll leave that to you to decide if that's a good or a bad thing. We're just saying where we see this going. Now, machine learning thrives on lots of data. Those of you who are data scientists in the room know that there is almost limitless, feels like limitless amounts of data, external and internal. A lot of that data is noise, so part of this power is being able to filter through the noise to work out what's really important in the data. But lots of data. Many data sources, external, internal, structured, unstructured. Now, the reality is, for you internally looking at these sorts of things, you probably want to start with some internal data sources. Some of the external ones are a little harder to manage. But in the longer term, you're looking at combining data from many different sources. High complexity. If it's simple, we could probably do it. But the machines are able to handle a complexity that humans can't. And enabling data scientists. So again, the human element is important here. The machines can't operate on their own. They need to be trained, they need to be validated, they need to be fine-tuned. So the data science teams working with the machines to get the results is key here. So why all the fuss? Well, digital business is increasing the amount of data. Digital business is also increasing the opportunities to get insights, to influence behavior, to monitor performance, to better manage assets. And all of this is too much for us puny humans. And we're at this tipping point where the machines are now able to do some aspects of that better than us, but they're not ready to take over completely. So we look at things like speed, power, efficiency, intelligence. These are some of the benefits that we get from the machine learning. Let me just quickly run through some benefits here. Speed, power, efficiency, I talked about. It is becoming more pervasive. So it's actually in things that you may not think of, and that's okay. Some of it you can just buy and use, but if your organization has a problem you want to solve, set up a project, set up a pilot, start to learn about these things. Machine learning can increase the functionality, and it can handle non-specific, unexpected situations. So it can help you start to identify anomalies or anticipate maintenance of assets, etc., etc. But it's not perfect. So here's some opportunities where it can get better. It will require lots of data and lots of computing power, typically. Now, some of the shallow learning you can still do on CPUs, you don't need GPUs. Some of the basic learning if you want to get started. But this deeper learning, the deeper neural networks, does require a lot of power. It does require a good data science team. You need people to work with the machine so they learn from each other. And there's areas of complexity. The last one, privacy and ethical considerations. Just because you can find out about people's behavior doesn't mean you should in all cases. And we expect that there'll be some litigation within the next few years for probably a retailer being sued for sort of mind control of customers over the next 3 or 4 years. So, do think about that. I was very pleased to meet Rita from CIMB and her colleagues. She's got colleagues from HR and risk. So, this is one of those things we have to work together to address the problems. It's not just technology alone. Well done, ladies. It's not guaranteed to work. It's still in the formative stages. And because these machines need to learn, as humans, when we learn, we don't always get it right. When a child learns to walk, they fall over a few times, right, before they learn to walk confidently. If you're learning to swim, you can't do that without getting in the swimming pool, and you're probably going to swallow a little bit of pool water. Machines aren't really any different when it comes to learning. They won't always get it right. And the technology, there's some great technologies out there, but they're still not fully mature. So Gartner has magic quadrants that can help you assess the different vendors in different spaces. This one is our data science platforms. Machine learning is basically data science applied. And we've got, IBM, SAS, SAP, various big names that you're familiar with, Microsoft. A few other lesser known ones that you might want to look at depending on the use case. Don't have time to go through that today. But the technology is maturing, but it's not fully mature. We do think that deep learning will provide best-in-class performance around demand, fraud, and failure prediction. Failure around physical assets, machines, utilities, transportation, fraud in financial systems, loans, etc., and demand in terms of B2C and B2B. So if you're in those areas, think about running some pilots and learning as you go. Now, machines aren't yet human, as capable as humans. They don't think like humans. Yes, the neural networks are based on the neural network in our brain, but they're nowhere near as sophisticated. They've got about 1% of the ability of the human brain still. Very good with high volumes of data and crunching stuff in a way that we can't, but limited in their in terms of the scope of what they can do at the moment. Now, many of the challenges you go through are organisational. Most of the organisation colleagues won't be familiar with this term. They won't be familiar with, they will have heard of AI, maybe cognitive computing, they may have heard of machine learning or neural networks, but they don't really know what that means or what you should do about it. So there's an education process. Much of the organisation will be potentially affected. So there's different parts of the organisation, as I mentioned, need to come together to learn how to manage the risk, how to operationalise this, how to build this into human behaviour. Where do the machines complement our skilled, experienced people? Where do they maybe automate some things that replace people? And where do we need new skills to be able to drive this in the future? And there's a lot of innovation going on around the computing, around the data architectures, around the data sources, Internet of Things, security, and various technology innovations that sit behind this. Just to wrap up, how do you get started? Well, this is about learning. So you need to learn, as well as helping the machine to learn. So set up some experiments. Set up some teams that come together, preferably multidisciplinary. You need IT people that know how to manage the infrastructure platform. You need data scientists who understand the data and the algorithms. And you need domain expertise in the business, whether that's in operations or risk or whatever it might be, to be able to define and identify what are your persistent problems and where might you run some experiments. So this is about learning, machine learning, but also human learning. How do we operate differently? You will need that high-performance computing infrastructure, particularly if you're going beyond the shallow learning to deep learning. Now, some of that you can access in the cloud. Doesn't mean you have to go and build a new data center for it. So a lot of this is available in the cloud. Start small and work with academia and specialty consultants, and obviously the vendors have people that can guide you through this as well. Think about some persistent problems that you have in your organisation that just won't go away and you haven't got the answer for. That might be an area to experiment with machine learning. The Deakin University case that I tried to share, we didn't get the audio working. He talked about setting up a team and running hypotheses. So create a hypothesis. Well, what if we did this? Well, let's try that. Let's run that through the machine. Okay, that didn't work, but let's try another one. Oh, that's interesting. All right, let's scale that up and put that into production. So this idea of experimenting, running hypothesis, and working out what works. Risk and adventure into deep learning only if you've got the required skills. So start shallow before you go deep. Like learning to swim, most people start in the shallow end of the pool before they go into the ocean. Inexperienced organisations will adopt deep learning-based solutions via APIs, applications, and external service providers, so cloud services and so forth. But I would encourage you, don't just rely on somebody else to give you the answer. Think about what's going on, what problem are you solving, how is that working, and how would we maybe bring some of this expertise more in-house in the future. This is an old quote from Jack Welch, former CEO of GE, but he says, an organization's ability to learn and translate that learning into action rapidly is the ultimate competitive advantage. If you want to learn about machine learning, don't wait. Find something, run an experiment, and learn. You don't learn to swim by standing on the side of the pool. You've got to get in the water and thrash around a little bit. Do it in a small way to manage the risk. Don't spend too much money. Don't do it in an open way. Start with internal data, but learn. This is about people learning as much as it is about machine learning. And as you do so, you can become the machine learning superhero in your organization. So, Gartner's got a lot of research, a lot of analysts in our large team of 1,200 analysts. Many of them are covering aspects of machine learning, AI, cognitive computing, all the different terms that go around this. We'd love to talk to you if you're a client further about this and help you navigate this process. Remember, the rate of technology-related change will never be as slow as it is today. Don't get left behind. Start now, but start small, stay safe, and have fun with machine learning. Thank you very much.